Hello, this is Lino Tadros, and in this third lab or exercise number 3, we're going to cut it down into 3 different videos. The first one, what I would like to accomplish is to get into something a lot more interesting, which is to implement contextual grounding using vector search in Azure CosmosDB for NoSQL. This would be very important to understand how Azure CosmosDB and what it brings to the table regarding embedding and vectorization automatically. Vector search definitely provides a powerful technique for efficiently finding information within blocks of text. When you decide to use CosmosDB, vector embedding generated using Azure OpenAI can be stored alongside data. And we're going to see actually during this exercise or this lab that you will be able to add vector search capabilities to Azure CosmosDB for NoSQL and perform similarity searches using the vectorized data. So let's go ahead and get started. All right, let's go head over to the portal again. We have all our resources that the bicep script have created for us. And this time I would like to see where my CosmosDB source is. There it is. That is the CosmosDB one that was created for me. And first of all, right now, when you just go ahead and provision a CosmosDB, it is not automatically enabled for vector search for NoSQL API. You'll have to add that feature, and it's pretty simple to do that. Notice on the left side under settings, there is something called features right there. If you click on that, you will see a lot of things have been turned off in here. The one I'm interested in is the second one, vector search for NoSQL API, and it's right now turned off. So I'm going to click on that, and then I'm going to go ahead and click on enable for this one. Wait a few seconds until you see the pending here going away. And once it says it's on, that means you just turn the feature of vector search for NoSQL API on, and you are ready to continue with everything else. So let's give it a second here to enable that. Usually it takes less than half a minute, and I'll be back once it's done. Excellent. After maybe a few seconds or so, it came back and said that the vector search is on. That means we are in a pretty good shape and we can keep going. For some of you that have never done this in their subscription, you might actually, when you turn it on, you might get a screen that says vector search for NoSQL API, and will give you a dialog that you'll have to enable and accept all the policies and the limitation that they are talking to you about. But in my case, because I've done that before, so I already enabled it, so I just have to turn it on. It takes a few seconds and we are done. The last thing I'll show you in this first video of the lab 3 is how to create a container, but this container will have to have the container vector policy enabled for it. So now that we are in the CosmosDB, let's go to the left side and see if there is a data explorer here that I can use. Let's take a look where I can see. There you go. There is data explorer. And you will notice in the data explorer, I will not have any containers. Or maybe there is one that was created that is completely empty, but hopefully not, because I don't want to create any new containers. We'll say thank you for that. And there is the container suite right there. And that's something that we will deal with later on. But remember, once the container has been created and confirmed, I can go back to an existing container and turn on vectorization on it. It has to be done during the creation of the container itself. After that, unfortunately, you'll have to delete it and recreate it if you missed that point. So in my case, I'm going to create a brand new container, and I'm going to use an existing one. So I'm going to say, show me the container suite, for instance, in here for that. And then the container ID, let's go ahead and choose a name. That's what we're going to call it. We are going to call it maintenance requests. Alrighty, so you can probably see where this is going. So maintenance request is the name. The partition key, I'm going to say /hotel ID. Okay, so I'm going to base all the partition in the NoSQL API for that specific NoSQL database on a partition called /hotel_ID. I'm going to leave everything else the same for right now. The one I'm interested in is the one that says container vector policy. Remember, you only have this during the creation of that container. You will not be able to add that later on after the creation. So we'll say add vector embedding. And there are some things in here that you will have to fill in. First of all, what is the path? And that path will be very important because this is how you're going to get to it from the code later on. To be able to get it. So in my case, I'm going to say /request_vector. I'm going to leave it as a float 32. And in distance, there is multiple ways to do it. I'm going to use the cosine. That means How to find out how similar or how close they are between all the vectors? I'm going to use the angle between the vector calculated in the cosine to find out if you're within range of what I'm going to tell you. The distance cannot be larger than whatever, and then you can give me back all the relevant documents or the relevant information that within the range, and it will be measured by the cosine for doing that. Remember, we're going to use ADA002, which has dimensions of 1536. Also, the newer ones like the ADA003 also has 1536 dimensions. If you're going to use one of the newer ones like ADA003 large, for instance, that is a 3000 dimension. So you'll have to match the dimension in here with the type of embedding model that you're going to use. In my case, I'm using the ADA002, and that is 1536 dimensions. That means this is the amount of floats that will be created for every single chunk inside of the database itself. Alrighty, and then the index type, this is an important piece. You can use flat, disk ANN, and quantized flat. Flat here, unfortunately, is not going to work. It will not work because it only supports a maximum of 505 dimensions, and we know we have 1536, so flat will not work. Based on the small amount of data we're doing this lab with, whether you use disk ANN or quantized flat, they both will do very fine with this stuff. But in the real life scenario, when you have tons and tons of data, disk ANN definitely is the way to go. So I would definitely recommend for you to concentrate on that. So I'm going to use disk ANN in here for us to be able to do that. Everything else needs to stay the same, and I'm going to say okay there, and then give it a minute, and that specific container with the vector policy will be created for the container and everything else. So we'll give it a minute and we'll come back once it's done. And indeed, after maybe half a minute or so, it came back. We'll notice the database for the Contoso suite in CosmosDB. Now we have a container called maintenance requests that definitely accept vectorization. I can open it up. Hopefully there will be no items in it whatsoever. I didn't do anything yet. We'll try to populate it in the next lab or in the next video for the specific lab number 3. But at least now I have a container that is ready for vectorization. Hopefully that video was clear to let you know how to actually enable a CosmosDB for embedding and vectorization, and how to set it up with a container with all the container vector policy that it needs to be there to set it up for success pretty much for the future of our lab. So let's go ahead and end this video at that, and let's go ahead and start the second one to show you actually how to create the vector store in CosmosDB itself. Thank you.